Good day, everyone. Today we are going to be talking about normal distribution, and the normal distribution is a continuous probability distribution that is symmetrically distributed about a central modal value, that is the mean. The probability distribution of a continuous variable is called a probability density function. Now, what are the characteristics of normal distribution? It should be noted that there is no single normal curve because the ideal situation is not always obtainable. But for a curve to be normal, it has to satisfy the following characteristics. The curve should be bell-shaped, as you can see in these samples that you see here. It is like a bell that is facing downwards. And also it is symmetrical about the mean. The mean is the middle point. Also, it coincides with the mean and the median, and that at that point the bell shaped or the curve is symmetrical because one side and the other are looking alike even though in the opposite direction. Then the third characteristic is that the mean, mode, and median coincide. Now, for you to understand this better, if you look at this diagram over here, this image, you will see that we have some histograms that are drawn in it. Then we now have a curve in line with the shape that the histogram form based on their heights. So what this means is that, let's say we are talking about scores of students in a class, for instance. Now, this is the modal score. This is the score that is more prevalent in the class, and therefore the number of people that got this score is higher than any other score, and this score is now in the middle. Now the other highest score is this one, followed by this, then till the end of it. So based on this, and again, the score here, let's assume this score is 50. That means this score here will be 40. For instance, let's say there's 10 different. This is 30, this is 20, this is 10, and this is, let's say, 0. And that means this will be 60, 70, 80, 90, then 100. So this is like a sample of how the distribution is. So if you look at here, why they say the mean, mode, and median coincide is that if you have the highest number of people having this course here, also, then that is why you have the mode. Then it will also be like the median score, because when you get the average of the scores of students in the class, it will still fall within this range. And also the mean, which is now showing that the mean is the average, while the median is showing that the scores is in the middle. So that's basically what this third characteristic is talking about. Now, moving forward, it said area on beneath this, the area that this distribution covers. What does it mean? Despite the value of mean and standard deviation, area under the normal curve is always equal to 1. We can therefore consider partial areas under the curve as representing probabilities. So when you want to, the total area under this curve is taken to represent to be 1 or 100%. So when you now want to consider some partial areas of the under the curve, then you can use it to mean probabilities or percentages, as the case may be. So now let's now explain the characteristics or the areas beneath the normal distribution curve. Here we want to talk about if you have a distribution this way, and the mean is here. So when you have any value or any score that is one standard deviation below the mean or above the mean, then in that situation you have you have 68.26% of the scores or of the scores of students falling within this range. What we are saying is that 68% of the students, if you look at the distribution here, you see that we have this is the highest, followed by these two. That means most of the students are within these three histograms that you see here, using the diagram here above. So then about 95.44% of the students are within 2 standard deviation away from the mean. We are saying that if you have 2 standard deviation away from the mean, that's those that score, this is 40, 30, 20, those that score 20 to 70 will form 95.44% of the students, and those that now score 10 to 80 or 90 will form um, 99.72% of the scores of the students. So that's basically what this is explaining, talking about. Now, note that the curve neither finishes nor meets the horizontal axis at mu plus or minus 3 sigma. It only approaches it and goes on indefinitely. So that's just the explanation on that. Now, in trying to now know how far off from the mean a particular score is, or a particular age is, depending on what you are studying, then you have to standardize you now have to calculate what they call a standardized value, which is represented by z, then to know how far off a particular score is from the mean. So now, in trying to do that, you have to there are procedures to do that. The first thing is to sketch the situation. At any point in time, you should be able to have a pictorial idea of how the diagram looks like, or how the distribution looks like. So you'll be able to sketch it, and sketch like this. Then depending on the values you are given in a question, you now plan it out and see what it should look like. Then from there you can now understand what solution you are asked to provide. Now the second thing is to standardize the value of x to give z. Now this is the formula that you use to do that. The standardized value represented by z is equal to x minus mu all over sigma. Mu here is the mean, while sigma is the standard deviation. So you want to know how far off this x is from the mean. So this is how you are going to calculate that. Now the next thing is to use the standardized table to find the area under the curve associated with z. So after calculating this z, you now check it in the standard table to know what is now the area that where the x represents beneath the curve. So if necessary, sometimes you may need to combine different areas that are found depending on the question. That will drawing the diagram or the sketching the situation will give you an idea of which part of it you need, whether you need only one side or the other side, or you need to combine two sides or two areas to be able to get the actual probability. So now the next thing is to convert this probability using area as found, since total area is equal to 1, or a percentage multiplying it by 100 and all that. So depending on what the question requires, then you know whether you leave it in the unit or you can convert it to percentage to now get the probability of that situation. Now, just a way of note: every normal curve, regardless of its mean and standard deviation, conforms to the following rule. This is like a tested rule, an empirical rule, that about 68% of the area under the curve falls within 1 standard deviation of the mean. About 95% fall under 2 standard deviation away from the mean, and about 99.7% fall under this. This is in line with the diagram we have above, the image here. When you look at it, you see that it will conform to that situation. If the curve is actually normal, this is how the distribution of the info data will be, and it will conform with that rule. So now let's given this illustration, for instance, you have in a particular school the average number of hours students study per week is 15 hours 30 minutes with a standard deviation of 4 hours. What is the probability of picking a student who studies at least 15 hours per week? Now we are trying to look for a student that studies at least 15 hours, but the average hours they study in a week is 15 hours 30 minutes. So the first thing to do here is to sketch the situation and see what the curve should look like. So let's say this is the midpoint. This is the point at which most students study. This is the highest number of hours that students will study. So it will be modal class, it will be the mean, and also the median. So here is going to be 15.5 hours. 15.5. Just pardon my writing. Now if you have it this way, it means the 15 hours we are looking for will be slightly below here. So we have 15 here. So we have 15 here. So if you have 15 here and they said they want you to study, to get a student that study at least 15 hours. So for you to have that, you have to look for the probability of studying between 15 hours and 15.5 hours then and more, because they say at least 15 hours. So the first thing to do is to sketch this diagram. You have already seen what is required. You know that here you need to combine this probability of this place and the probability of studying more than 15.5 hours. So you now calculate the z value, which is the x minus the mean divided by the standard deviation. So you get minus 0.125. Going down to the table, let's check this in the table. We go to the table, you say minus 1 2 under 0.125. 0.12. This is 0.1, 0.12. The 5 there, if you say make it 0.3, it will be too high. So it should be the value is between this. So let's just pick the lower level. So it's 0.048. So when you come up back, you see that you have 0.048, which is approximately 0.05. Are we together? So now based on that, if you have 0.05 and we know, sorry, let me check again, this is 0.05, yeah, approximately. So if you have 0.05 as the value here, this is the value here, right? Then we know already that this is already midway to this is the half, the middle of the curve, which means these people studying above 15.5 hours are already 50% of the class, or of the students, which is 0.5. So if you add this 0.5 plus the 0.05, it will give you 0. It will give you 0.55, which is this is your answer here. But the way it is solved here, they did it the other way around, meaning the total area under here is 1. minus the z less than 0. If this is 0.5 here, then if you, and we know that what they just did is a reverse calculation. They know that the entire here, the whole of this place is 0.5. Yeah. So if you remove 0.5 minus this place alone, you have 0.45. So they removed that from the total. It's just a reverse calculation they did, and they got this. But this is the same solution you are going to get when you use this method I just explained. So that is it. The second question is still based on this first question. Based on the illustration 1, assuming that an exam is coming, every student is putting in an extra 3 hours of study per week. What is the probability of picking a student who studies at least 20 hours per week? Here, we are going to have a shift. If every student had, before the mean was 15.5, if everyone had 333, then the 15.5 will become 18.5. So that's why we have this 18.5 as the mean now. Now the question now is talking about at least 20 hours. So here we have 20 as our x. So the standard deviation remains the same. Why is the standard deviation remaining the same? Irrespective of how, in as much as everyone increased 3 hours, the deviation of one score of the hours of a student to another is not changing, because everyone has increased the total of 3 hours. So that's why that stay the same. So by the time you calculate this, you are going to get 0.375. So but the first thing is this: let's sketch out this so that we'll have a picture of what our answers should be. So if you have here 15.5, it means here is going to be what? 20. Here will be what? 20. So if here is 20, it means if they said we want those that are above 20, then it will be what? At least 20. It will be this place. So this is what we want. So when we calculate, the only thing we can calculate here is to calculate this portion. So when we calculate this portion, we can now remove it from 0.5, then we get the one that is above. So based on this calculation now, we have the z to be 0.375. So let's go to our table. We will check 0.3 under 7. 0.3 under 7. So if we go with 0.3 under 7, we have 0.443. So when we go back up, if you have 0.1443, that if this is 0.1443, this is for this place. Then if you remove this from 0.5, you get the answer. So you've said 0.5 minus 0.1443 to be 0.36. So that's just that. The same way here, they solve it using the reverse method by removing they use the reverse method, and that's how they got this. But this is still the same. When you remove this minus this, now you get 0.36, and that is it. Another question here is to estimate likely expenditure by customers at a new supermarket. A sample of till slips from a similar supermarket describing the weekly amount spent by 500 randomly selected customers was analyzed. These data were found to be approximately normally distributed with a mean of 50 naira and a standard deviation of 15 naira. Use the information to answer the following questions. We have, what is the probability that any shopper selected at random spends more than 80 naira per week? The other one says spends less than 50, and here we have spend between 30 and 80. So anytime you are having more than or less than, you know it's going to go the other way around, from 80 above or from 50 below, or between 30 and 80, as the case may be. So now for this first question, you sketch out the situation. When you sketch it out, you now see that we have this is the sketch, and this is the middle, this is the mean. You have the mean here. So the mean is 50, the standard deviation is 15, and the x we are looking for, what is 80. So we say 80 minus 50 all over 15, you have 2. So when you go to the table now, you check 2 under 0, you have 0.4772, and that is all for that question. So the probability there is, let's go here, they said the probability there is 0.4722, but what we are actually looking for is the one that is above 80, not between 50 and 80. And even we are looking for between 15 and 80, it should just be this place, and the answer will just be this directly. But because it is above 80 that we are looking for, 18 naira, so it will be this shaded area. So how do you get that? We already explained earlier that the total of this side is 0.5 or 50% already of this cost, or of the number of spenders, or the amount. So now we will now set 0.5 minus 0.4772, because 0.4772 is representing this area that is labeled Q. So we have 0.0228, and that is it. And if you check again, this is, if another explanation to this is that if you check, this is this Z means that this 80 is 2 standard deviation away from the mean. And we already said earlier that anything that is 2 standard deviation away from the mean, 95% of data will fall above that, below that, around that. So when you have that, it means it's only 5% that is left. That's why we are not disputing this answer that we got 0.0285. This is about 2%, because 2% already are going to be here. I don't know if you I hope you understand that little addition. Now the second question is the probability that someone will spend selected at random spends more than 50 naira. So there's no need to do any calculation for this, because even though you can do the calculation, you still get the answer. But by simple inspection, you will get it that this is already 50. If you say somebody spend more than 50, the total number of 50 people spending more than 50 here is going to be 50% already, just based on what I explained here by saying 0.5 minus 0.477 for this area. So that is that. But if you still want to solve it, it's just to say 50 minus 50 all over what? 15. So you have 50 minus 50, you have 0. Divide by 15, you have 0. So when you go and check your table, when you check your table, you check 0 under 0, you are going to have, I think that yes, there's a little. So you have, if you check 0 under 0, you are going to get 0.05. You are going to get, so at that point 0.5. So at that point you see that I think there's a problem with that table that we have down there. So at that point you have the same 0.5, so there's no point to even solve it. Another way you can look around it is what is the have they will have 500 shoppers. Half of them is 250. 250 divided by 500 will still give you 0.5. So in any way you look at it, you know that the answer is 0.5 for that question. The next one we are looking at is the probability that a spender will, a shopper will spend between 30 to 80 naira per week. We need first, what do we need to get? We need to get probability 30 is less than x and x is less than 80, meaning the person spent between 30, x is greater than 30 and less than 80. So this is the probability of what we are looking for. So if you look at it in the sketch here, we have 50 here, we have 80 here, we have 30 here. So what's the probability that someone spent around this shaded area? Between 30 to 50, 50 to 80. So this is the calculation you are going to do. So the first calculation you are going to do this side, let's say as it is labeled Q1 and Q2. You do for Q1, you do for Q2. For Q1 is just saying 80 minus 50 all over 15, you get 2. And we already calculated it above as 0.4772, that's shaded area. And in the first question we are looking for more than 80, so we had to remove 0.5 minus, we have to calculate 0.5 minus 0.4772 to get that portion which is above 80. But in this case we are looking at the area between 50 and 80 and area between 30 and 80, so this is just what we need. So after that we will now calculate for 30. 30 minus 50 all over 15, we have minus 20 over 15. So if you minus this, you have minus 1.333. So let's go to the table and see minus 1.33. So if you look at here, you see 1.3 is 0, 1, 2, 3. So this is the value here. But we have 1.3333, so there's still 333. So which means this is 1.34. So the value is supposed to fall within 0.4082 and 0.4099. So how do we treat that? If we want to do this, we can do what they call interpolation. How do you go about it? You said the z that we got is minus 1.333, and based on that, if we are to interpolate, the value we are going to get is from the table we got 0.4082 when we look at it under 1.33, but there's additional 3. So we can say, if you look at the table, you see this value is supposed to lie between 0.4082 and 0.4099. If you look at the table, the next value after 1.33. Now, and if you check what is the difference between this and this, you see there is 0.017. So which value of this have you not seen in the table? Is the 0.3, is 0.333. Now what I mean is this: we have 1.333 and we are only able to check 1.33 from the table, so remaining 0.003. So you can easily just take this value, divide it by 3, this because this one is like a quarter. So if you get a quarter of this, which is 0.0006, if you add it to the lower one, which is 0.4082, you get 0.4088. That is how you came about this 0.4088 by interpolation. So that's basically how it was calculated. So now for you to get the area between for the probability of spending between 30 and 80, you have to add the probability of spending between 30 and 50, then probability of spending between 50 and 80. So that is how we came about this now, and we have 0.4088 plus 0.4772, and it became 0.8860. If you convert it to percentage, this will be 88.6% of the shoppers we are going to spend between 30 to 80 naira. I hope this answers this has explained it enough. If you have any further question, you can ask me.